gonna happen.
So we gotta do 2, 3, and 4.
2 and 4.
2 and 4. Or 4.
Well, no need 2, 3. Okay. Find an equation for the sphere. X squared plus y squared plus z squared plus, no, z minus b squared equal b squared. Okay, so, okay, let's draw the, whenever you get stuck, draw the box. Okay, so this is x, this is y, this is z. That's rho, right? Rho is how far you are from the origin. That's theta. Remember, these are right angles here. And then that's phi. So what you need to do is substitute. Well, look at this picture. Isn't rho squared equal to x squared plus y squared plus z squared? Because it's a diagonal of a rectangular box.
Yes.
Okay, and then what about theta? Well, theta is not in this problem. You know. Well, let's just do this. Multiply this out. You get x squared plus y squared plus z squared minus 2bz plus b squared equals b squared. The b squareds cancel out. That's rho squared right there, right? So rho squared is equal to 2bz. So we just got to know what z is. But we did that yesterday. No, if this is phi, wouldn't that angle be phi
Yes.
also?
Yeah.
So since you have a right triangle here, z would be rho cosine phi. So
Oh, I know that.
rho squared is equal to 2b, and what is z? Rho cosine phi. Divide both sides by rho, because rho equals 0 is already part of the solution. Rho equals 2b cosine phi.
Yeah.
The reason why I put that problem on is because then that comes up in number 4, right? Because then you know it's a sphere. That this is the sphere. The center is at 0, 0, b, right? With radius b, that means it's gonna what does that sphere look like? It goes through the origin, right? And the radius is b, like that. That's the sphere in number 4, except then it's going to be 2 root 2, yeah? The diameter is 2 root 2 instead. All right, let's do number 4. So Cho came in for help and we were doing the problem. Took a while yet to get the answer.
Yeah.
Because you got to think about a lot of things. Number 4. So did you guys at least get a picture? Rho equals 2 root 2
Okay, wait. I had
cos
a question about the picture. So, like, I was
of this, I hope.
what?
Yeah.
Of this one.
Yeah.
Okay.
Wait. So, when I was confused on the rho equals 2 root 2 cosine phi, and then I graphed it on a 3D graphing calculator, and it came out like not a sphere. I was really confused.
Maybe because of the scaling. Well, what did it look like?
It looked like
An ellipsoid.
it was like no, it was like not a. It was like a teardrop or something. Yeah.
No, it's a sphere.
It was a teardrop from the.
Wait, you have a 3D graphic calculator?
No, it was on the iPhone.
Oh.
You still have it on
You
there?
pay for
No, it's free. Maybe that's why it's free.
it.
Okay, so we have a sphere. The diameter is 2 root 2 like that, yeah? So that's the sphere. And then here's another smaller sphere that's like center at the origin, those are smaller diameter.
Wait, how do you know how to draw the top one?
Because we just did that in problem 3.
Oh.
I mean problem 2. Remember problem 2?
Yeah.
Oh, so then.
It's like the exact same
Oh.
equation, yeah? So you know it's a sphere going through the origin, tangent to the xy plane, yeah? Like that. So that's why the problem was on there. So anyway, so basically you got 2 spheres. Gosh, I can't draw. Find the volume of the solid bounded by the 2 spheres. I'm going to draw another picture here. got a bigger one and then a smaller one. One on top of the other. Okay, gosh. But then they both, gotta go through the origin, it's like, okay, here's the origin. Okay, that's better. So now you gotta remember, these are spheres now, these are not circles, these are three-dimensional, yeah? So, it's like that. So find the volume, so what we figured out is you gotta do two separate integrals. So it's kind of like, okay, here, let's draw a side view of the thing.
Isn't it all side? Or
No, look, I tried to make it 3D. So like, think of two circles like this. You connect this like, how do you find this area there? Don't you find the area of this, and then you find the area of that? You gotta make like, because the circles have different radii, that's why, right? Same thing with the sphere. So what you gotta do is find the volume of the bottom region and then find the volume of the top region. So you're gonna have to make separate integrals. Okay, so which one is the easy one? The bottom one, yeah?
yeah.
What? XZ?
Oh shoot. X, Y, Z. Okay, so triple integral. We're gonna do the bottom part first. So rho squared sine phi. I'm just gonna set up the integral here. So we're gonna integrate with respect to rho first, d rho. Now rho, now we're just talking about this bottom region right here, right? Rho is gonna go from here to there.
0 to 2.
So we need just that part there, so like here, rho, so rho is gonna go from 0 to the equation of this curve right there. What's the equation of that curve, which is the upper sphere? 2 root 2 cosine phi. Okay, then we're gonna integrate with respect to theta. Now theta, remember, is like the angle on the xy plane, right? So that one you have to go all the way around, 0 to 2 pi. And then you integrate with respect to phi. Now phi is the angle that it makes with the positive z-axis. So what is that gonna be? How do I figure out that angle of phi right there?
Pi over 4.
Yeah, how do you figure that out though?
You set the two equations equal.
Okay, there you go. So if you set these equations equal, like where they intersect basically, so you get 2 equals 2 root 2 cosine phi. Cosine phi equals 1 over root 2, so therefore phi is pi over 4 then, yeah? So, but you got to remember, phi is measured from the positive z-axis, so this is 0, pi over 4, that's where they intersect right there, and then going all the way down to 0. So the limits are, not 0, pi over 2. So the limits are going to be from pi over 4 to pi over 2. You guys understand that? Phi is measured from the positive z-axis. So this is where phi is 0, pi over 4, and then if you continue on like that, pi over 4, until you hit there, then phi is pi over 2. Cosine, because look, cosine of pi over 2 is 0, right?
Wait, sorry, can you clarify why there has to be two integrals?
Because it's just too difficult. I can't figure out another way to do it. So to find the area of this bottom part, it's going to be the volume of this stuff, and then what's left is a cone, yeah, on the bottom. But then it's easy to figure out the volume of a cone. We don't even have to use an integral for that, right? A cone just 1/3 pi r squared h. We can do that.
Wait. The second integral calculates the
Oh, the rest of it.
Yeah.
The rest of it. Okay, then we can do that too. Okay, but first you gotta understand, this integral represents this, the area, not the area, the volume of here's a cone here, outside of that cone, but inside of the upper sphere. Yeah.
I'm confused about why it's from pi over 4 to pi over 2.
Because phi is measured from the positive z-axis. From the positive z-axis. So, where is phi equal to 0? Right on the z-axis. And then it sweeps, so here's the positive z-axis, and then as you come down, like that, see, that's phi. 0, pi over 4, and then when you hit the xy plane, then it's pi over 2.
Oh, so then this is 0.
Yeah, right on the
Right,
z-axis is
it's
0.
Okay. and-
So like here, so 0, like I said, 0, pi over 4, and then pi over 2, it goes to there.
Oh, so you take the
Just like polar coordinates, you gotta know
difference
how
angle
it's
of the
being
bottom
formed.
part.
What?
You take the difference of the angle from the bottom part, or like, cause.
Well, that's why you have to figure out where the graphs intersected, right? They intersected right there. And what is the value of phi right there? It's pi over 4. So that's why 0 to pi over 4, that's not the part we want. We want after pi over 4. Pi over 4. See, how is the sphere being formed? Here. Phi is 0, pi over 4, and then pi over 2. So this part is being formed from pi over 4 to pi over 2. Just like you gotta know how polar coordinates are being formed, you got same thing with spherical coordinates, you gotta know how it's being formed. Okay, so this integral represents that region right there. Now, the rest of the region is basically this cap over here, plus the cone. But then we can do that with just one integral. So we're gonna do another triple integral. Rho squared sine phi. So let's integrate with respect to rho first, I guess. D rho, to put the plus sign closer. D rho. So to figure out that region there, rho will go from what?
0 to 2.
No, from there all the way to there.
0 to 2.
Yeah, 0 to 2. Was that what you said?
Yeah.
Okay, then you were in respect to theta. Well, theta is this angle on the xy plane again, so you gotta go all the way around. So that's 0 to 2 pi. And then when you integrate with respect to phi,
Same thing.
phi is gonna go from.
Oh, it's
So now you gotta think of the smaller sphere here. Phi is gonna go from 0 to
power 4.
pi over 4. That's right. So you add up these two integrals, that would be the volume. See, that's the hard part. You gotta make separate integrals. Okay?
That was.
It's not easy to do. Plus, if you're not used to spherical coordinates, then it's kind of tough. I will leave it up to you to compute. These integrals weren't hard to compute, huh? Show.
Wait.
Wait. No, you ended up with a cosine to the 4th, yeah? Because when you compute this integral with respect to rho, you're gonna get 1/3 rho cubed sine phi from 0 to 2 root 2 cosine theta. Then you gotta plug this in over here.
But you can just use U substitution.
Oh yeah, that one is just U substitution. That's not even hard then.
Wait,
Yeah.
Wait, why wouldn't you be able to do like, have the limits be like 0 to 2 pi?
For what?
For like, if doing one integral, like, I'm still not clear on why you can't do one.
Okay, what would it be then if you just did one?
Wouldn't it be like 0 to pi over 4?
Okay, so first one, respect to rho.
There's 2 curves.
Respect to phi, 0 to pi over 4. I mean, 0 to pi over 2. Oh, wait, sorry, I was going from the other way. Sorry. Like, with respect to rho,
Okay.
it would be like 2 to 2 cosine.
Say that again.
Wait, no, sorry, 2 cosine phi to 2. And then.
Wait.
Does that not work?
That would work.
Okay, then finish it, I gotta see the rest of the limits.
Like,
So d theta goes to be 0 to 2 pi, right?
yeah,
And then d phi,
0 to pi over 2.
so that's from there until you hit the xy plane, right?
Yeah.
Okay, this is the problem here. It goes from this one to that one. So that would be like, like from this one, the outer one, to the inner one. Like that doesn't make sense even.
I'm so confused.
The outer to the inner one.
Well, isn't that like,
How do you go from the outer one to the inner one? Oh, but then over here, this is the inner one, right here, right?
yeah.
So it's gonna go from here to there. So that's like this,
Oh.
that part over there.
Oh, it's
So what
because-
you're computing is this part out here,
The one happened.
the part. No, he's trying to do it with one integral.
So what's the result?
You can't, because if you go from this sphere to that sphere, so from, oh, but you're going from 0 to pi over 2. So if you go from 0,
Oh, then you
then
get
you're going
the
from
negative
this
of all
one
of that,
to
yeah.
that one, so you're computing this volume over here.
Oh, so it's because
That's over
they're
here.
at different values of phi at different like points along the curve.
Yeah, because
Oh.
from 0 to pi over 4, from 0, when phi is 0 to pi over 4, this one is outside that one, yeah?
Yes.
But then from pi over 4 to pi over 2, then this one is outside that one. It kind
Okay.
of switches.
Oh, oh, so future.
So, yeah, I don't think you can do it with just one
That makes
integral.
sense.
Okay, that's pretty tough. Now luckily for you, most of the integrals on the test, you just have to write the integral. But there are a few of them where you actually gotta compute, like especially the centroids, you're gonna have to compute the centroids. Those are the fun ones.
Like, how many points would I lose if I wasn't able to integrate anything?
6 points, right?
Theoretically.
Well, I don't know. I forget how many problems are actually on the test. What, are you planning something devious already?
Why would I plan to get them wrong on purpose? No, like I just know.
You guys are experts at computing
I'm
integrals.
really bad at computing integrals.
Okay, today is the last section. We're computing surface area, but surface area pretty much is just a function. I mean, it's just memorize the formula.
You have a drawing.
Yeah, if you look in the book, they have one, but I don't know about the proof. I think something about it says it's beyond the scope of this book.
Oh, that's like the length of the line.
Yeah, kind of, like, yeah, kind of, but. Okay, so if you look at your notes, surface area is equal to double integral over omega. Now, omega is like what happens when you smash it down onto the xy plane. That's the tricky part. So you can have a surface up here, but to get omega, you gotta smash it down onto the xy plane. Square root of partial of f with respect to x quantity squared plus the partial of f with respect to y quantity squared plus 1 dx dy. If you're doing it in rectangular coordinates. Find the surface area of the part of the parabolic cylinder. Okay, you know what? You guys are gonna do these. Let's do some other examples. Like what do we want to find the surface area? Let's do the paraboloid. Are you doing a paraboloid today?
Yeah.
No, that's a hyperbolic paraboloid.
No, it's right there at the bottom.
Oh, dude.
Oh yeah, okay.
Let's do.
That's it.
No.
With different numbers.
Number one. Can you do number one?
Why?
It's just hard.
Find the surface of the part of the parabolic cylinder z equal y. No, that's easy. No, that's easy. Okay,
Okay, then.
let me think about it. Okay, I was gonna do a paraboloid.
Let's do.
Okay, let's do number 3.
That's the easiest one.
Yeah, I know, that is.
It's your.
Okay, so we got z is equal to 1 minus x squared plus y squared quantity. Already, what are you thinking when you see this? What are you thinking?
R squared.
Yeah, you're gonna do polar, yes. If you integrate it in polar, it'll be a lot easier. Okay, so remember this is a paraboloid. Upside down, shifted 1 unit up. So it's kinda like, how do you draw it, gosh?
Do we need to know how to like
Something like that.
draw those weird
I,
things again?
look, I can't even draw it.
Oh.
Anyway, what is the surface area of a paraboloid? So what you gotta do is compute partials. What is the partial of z with respect to x?
Negative 2x.
Negative 2x. What's the partial of z with respect to y?
Negative 2x.
Negative 2y. Throw it into the formula. Double integral square root of negative 2x squared plus negative 2y quantity squared plus 1 dx dy, okay, over omega. Now, omega is what you get when you just smash everything down onto the xy plane. So if we look from above, smash down, isn't it just going to be a circle of radius 1?
Oh, yeah.
Okay, so we already know we're going to do polar, so it's not going to be dx dy. What is it going to be? R dr d theta. Right, remember? Okay, and then when you simplify this thing right there, that's going to be 4x squared plus 4y squared plus 1. If you factor out the 4, you're going to get x squared plus y squared plus 1. So isn't that just 4r squared plus 1? Okay, now you remember we're doing this in polar, so what are my, so here's omega. What is r going to go from? R is going to go from 0 to?
1.
Yeah, it's all constant every time, so 0 to 1. And then what about theta? 0 to 2 pi. And look up,
Did you say that it's just pi? Because it's circle?
not this circle, the other circle.
What do you mean?
Not every circle. This circle, r equal 2 cosine theta. That circle is drawn just from 0 to pi. Not this one. This one gotta go all the way around.
Oh.
So everything besides like that.
You guys just wanna memorize things, is that it?
Wait, so if
No,
it
just
has,
look at it.
so if it has a cosine, then it's from 0 to pi.
Or sign.
For a sine.
Okay.
Oh my goodness.
Wait, R equals 2 sine theta is a circle too.
Yeah, that's a circle, except it's
It's
like,
on the Y.
it's like over here.
Oh, no way. Wait, so when you have cosine
Yes.
and sine, it just shifts?
Yeah.
Yeah,
Oh!
we did this at PCH,
It was like
Wayne.
water X.
You were in my
That's
class.
many years
Oh wait,
ago.
no, I thought he was drawing sine, that's why.
Yeah, sine is up there.
Because he
like
said
that.
R,
Like that.
R2 sine is that, and then he
Oh my
put it
goodness.
underneath the cosine.
And look how easy this integral is, use substitution.
Okay.
Okay, I think you guys can handle that. So surface area. I got a good one for the test, I'll just say that.
Oh,
Don't you guys like doing challenging integrals?
No.
of course.
Okay, were you guys here? No, I was only talking to Cho. Remember that problem that had the super long integral? Remember that?
Number 3, event 2, I mean like worksheet.
Yeah, remember
Yeah.
it was the area bounded by the ellipse? No, the parabola, and what's the other one?
What was
It was like MVC.
Somebody- Okay, so this is a parabola. If you plot the quadrantal angles, what do you get? 1/2. One. So the parabola, and then the other one was a circle. R equal 1.
Wait.
Yeah, it was a circle. And we had to find the area.
Oh yeah, R equals 1.
You guys don't remember that? Remember that super long, you had to do a, remember,
Oh, it's
we didn't even finish it, and then you had to complete the square,
Yeah.
and then,
You found an easier way to do it.
yeah, I found an easier way to do it.
Is it faster?
Yeah, watch this.
Watch it.
Okay, would you agree the area of the shaded region is simply the area of the semicircle? That,
Nice.
oh, this is supposed to be it's supposed to be a circle. That's terrible. The area of the semicircle minus this parabolic region there.
Yeah. Oh, you can just
So-
integrate the.
Yeah, no, we don't even have to do integrals. What's the area of that semicircle? Half a circle of radius 1.
pi over 4.
No, pi over 2.
Pi over
Minus a parabolic arch. Now remember in calculus we were taught that Archimedes proved that if you have a parabolic arch, then the area is 2/3 base times height.
Oh, yeah.
Oh.
Base and height. This is a parabolic arch because this is the equation of a parabola. So minus 2/3 base times height. Well, what's the base? What's this distance right there? 2. What's the height?
1.
No,
Half.
it's a half. So the final answer is simply pi over 2 minus 2/3.
Wait, how do you compute the area of the parabolic region without,
2/3 base times height.
well, with integrals?
Oh, we did it, remember?
Wait, how?
Remember we had to do the z substitution, and then you had to factor it, and then you gotta complete the square. You guys still never finished it, huh?
If this question comes up on the test,
It's not.
No, I'm not gonna, no, on my test, I don't put any two-dimensional ones, they're all three-dimensional. Even the centroid one is three-dimensional.
Oh. Can you make
Everything is all three-dimensional.
Oh,
I didn't put any two-dimensional problems on there. Don't worry.
so we don't have to compute the central.
We do.
For 3 coordinates?
yeah.
Yeah, but some of it will be symmetric, so you don't have to compute all x, y, and z.
Could you tell us what the surface is like?
So you can get a head start.
Yeah.
No! No, I am not. Okay, all I tell you is you guys gotta work quickly on this test, because if I were you, I would just set up all the integrals and then go back and then actually compute the ones that you think you can do.
Oh, gosh.
But some of them are easy, like this one. You convert it to polar,
No.
do substitution.
How do you do your substitution for? I just tried and I couldn't.
Are you serious?
Yeah.
Okay, so this is 4r squared plus 1, right?
Yeah.
So if you let u equal to 4r squared plus 1, du is equal to 8r dr. So this first integral is radical u, right?
Yeah.
And then you have r dr, so what do you substitute for r dr? 1/8 du. And what are your new limits going to be? 0 to 1. So what happens when you plug in 0 there? You get 1. And what happens if I plug in 1 there? You get 5. So you're going to get 1/8 u to the 3/2 with a 2/3 in the front from 1 to 5. Factor out the constant. So what is that? 1/12. 5√5 minus 1.
Wait, like, how do you know that, like, u is 4r squared plus 1 instead of, like, square root of 4r squared plus 1?
Because I took calculus. No, because remember, when you make a u substitution, whatever your derivative is needs to be in the integral as well, right? See, so like if that was an r cubed, then you would need an r squared over here in order for u substitution to work. Wayne, we cannot forget u substitution. That's like the most basic one. That's the one they tested you extensively on the BC exam, where you got a 5, I may add. And then, of course, when you integrate from 0 to 2 pi, just multiply this by 2 pi, and that's your answer, yeah. Well, you guys should be ecstatic if you get one that's simple, where you just do u substitution. Because I'm pretty sure if I remember the test from what did last year, there probably is a trig substitution. Okay, there won't be a z substitution, but I'm pretty sure there's a trig substitution. All right, so we are done with this chapter. So do I see you tomorrow? Yeah, so tomorrow we just go over whatever you need to go over and then study for the test on Monday.
Study for the test on Monday.
No. Then the homework is to study for Monday's test. Not, well, I guess for some of you, you can study for the test on Monday, huh?
Yes. Wait.
We
Is it